Step back in time with me for a minute to look at one of the absolute greatest unsolved mysteries in natural history. Welcome to this explainer. Today, we're digging into the largest cosmic explosion ever witnessed by humanity. It's an event so staggering in its sheer scale that it fundamentally rewired how we understand Earth's vulnerability in the universe. Picture this terrifying scenario. What if an explosion significantly stronger than a nuclear bomb struck the Earth, but left absolutely no crater behind? Like, how is that even physically possible? We're going to dive right into this because this single, haunting paradox has puzzled scientists and fueled some wild imaginations for well over a century. To wrap our heads around the mystery, we have to travel to one of the most isolated, unforgiving places on the planet. The morning of June 30th, 1908. We're in a remote, desolate stretch of the Siberian wilderness. In just a fraction of a second, an incomprehensible blast absolutely leveled the landscape. 80 million trees were instantly flattened, laid out across roughly 2,150 square kilometers. Just for some context here, that is an area of absolute destruction larger than most modern metropolitan cities, completely wiped clean in the blink of an eye. The eyewitnesses who happened to be near the Podkamenia Tunguska River described an apocalyptic scene. They reported seeing this intensely bright fireball streaking across the early morning sky. It was described as being literally as blindingly bright as the sun itself. And moments later, a massive shockwave violently swept over the landscape. People hundreds of kilometers away felt an intense, blistering heat and a deafening blast that shattered windows and literally knocked them right off their feet. When modern scientists actually sit down and calculate the power required to cause this level of devastation, the estimates are just staggering. The energy release of the Tunguska event was somewhere between 10 and 15 megatons of TNT. To put that into terrifying perspective, the atomic bomb dropped on Hiroshima was 15 kilotons. We're talking about an explosion nearly 1,000 times more powerful. So the crucial point is this. With an explosion 1,000 times more powerful than a nuclear weapon, you would naturally expect to find a massive gaping wound in the Earth, right? A crater miles wide. But there was absolutely nothing. The missing crater is the central paradox of the Tunguska event. The Earth was completely scorched. Millions of trees were destroyed, but the ground itself bore no impact crater whatsoever. Now, because of the extreme remoteness of the Siberian wilderness, which was compounded by some severe political turmoil in Russia at the time, this grand mystery went almost entirely unexamined for nearly 2 decades. It wasn't until 1921 that a Russian geologist named Leonid Kulik was finally assigned to investigate, and it took him until 1927, 19 years after the blast, to actually reach ground zero on what was an incredibly arduous expedition. When Kulik and later scientists finally started mapping the destruction, they found a massive, butterfly-shaped pattern of felled trees, all pointing radially outward from the center. But at the very epicenter of this destruction, they found something incredibly eerie. There was a forest of trees left completely standing upright, but entirely stripped of their branches and bark. They looked exactly like giant, scorched telephone poles. The complete absence of a meteorite, a crater, or really any obvious smoking gun at the epicenter created a massive vacuum of understanding. And as you know, nature abhors a vacuum. Almost immediately, this lack of physical impact evidence fueled decades of wild speculation. It drew in everyone from genuine, rigorous scientists to incredibly imaginative conspiracy theorists. Just look at the list of theories that have been proposed over the years. We have everything from a miniature black hole passing right through the Earth to the explosion of a nuclear-powered alien spacecraft, an antimatter collision, secret electromagnetic weapon experiments, or even a massive tectonic natural gas eruption. Look, while these ideas are wildly imaginative and, honestly, pretty fun to think about, mainstream science universally rejects the exotic ones. Why? Because they completely lack any supporting physical or geochemical evidence. So, what really happened out there? The ultimate scientific consensus points to a phenomenon known as a cosmic airburst. Imagine a stony asteroid or a fragment of a comet roughly 50 to 60 meters wide. It hits Earth's atmosphere traveling at an estimated 100,000 kilometers per hour. At that incredible speed, the high pressure and extreme friction cause the object to explosively disintegrate. It literally evaporates in the dense layers of our atmosphere about 5 to 10 kilometers above the ground. Fast forward to today, and we rely on advanced hydrocode simulations. These are the same incredibly complex physics models we use to analyze nuclear airbursts. These models show that the asteroid's kinetic energy was deposited directly into the atmosphere. This created a massive vertical shockwave that acted like a crushing wind column. It slammed straight down onto the forest, which perfectly explains why the trees directly underneath were left standing but stripped bare, while the blast winds radiated outward, knocking down everything else in its path. And while there isn't some giant rock to point to, there are definitely chemical fingerprints left behind. The high-altitude dust from the vaporized object spread high across the atmosphere, creating unusual, glowing, bright nights across Europe and Asia. It was so bright, people could literally read newspapers at midnight. Furthermore, periodic sampling of the peat bogs at the site has yielded microscopic magnetic spheres containing nickel and iridium. These are signatures that strongly confirm an extraterrestrial origin beyond a shadow of a doubt. Which brings us to a rather chilling pivot in our story. Because understanding the mechanics of Tunguska isn't just about solving a century-old historical curiosity. It's about understanding a very real, very present danger. What would happen if a Tunguska-sized object didn't fall over the isolated Siberian wilderness, but instead targeted a major modern metropolis today? The numbers are downright horrifying. If a similar 50 to 60-meter asteroid detonated as an airburst over a city like New York, it would utterly destroy an 800-square-mile area. There would be absolutely nothing left standing in that zone. The casualty estimates run into the millions. It would be a catastrophe of truly unprecedented proportions. And we really don't even have to look back to 1908 to know this threat is real. Do you remember the Chelyabinsk meteor in 2013? A much smaller object, only about 18 meters wide, exploded 14.5 miles above a Russian city with the force of 30 atomic bombs. The shockwave blew out windows, damaged buildings, and injured over 1,500 people. And remember, that object was just a fraction of the size of the Tunguska impactor. Our solar system is essentially a cosmic shooting gallery. Modern monitoring systems meticulously track the near-Earth object population. And while the massive planetary killer asteroids are exceedingly rare and heavily monitored, there are millions of smaller objects out there. Statistically, an asteroid the size of the Tunguska body crosses Earth's path roughly every few centuries. But there is hope here. This is exactly why agencies like NASA have established rigorous planetary defense strategies. By studying the physics, the airburst mechanics, and the energy yields of the 1908 event, scientists are way better equipped to model future threats. We aren't just sitting ducks. Understanding Tunguska is absolutely crucial to developing mitigation technologies to prevent a devastating cosmic airburst from ever catching us off guard again. Ultimately, the Tunguska event remains one of the greatest natural history milestones in human existence. It stands as a profound legacy because it proved to a highly skeptical world that catastrophic impacts are not just ancient history relegated to the dinosaurs. They are a permanent, dynamic part of our reality. The missing crater didn't mean there was no impact. It just meant the atmosphere took the hit for us. We live on a fragile world, floating in a chaotic, rubble-filled solar system. We are absolutely getting better at watching the skies, but the universe is vast, and a lot of small rocks remain hidden in the dark. So I'm going to leave you with this thought to ponder. Could another Tunguska-sized object already be heading toward Earth right now? Thank you for joining me on this explainer, and keep looking up.